Hello students, we are studying the unit 3rd. In unit 3rd, we have to study the permission blockchain, various consensus algorithm, use cases, benefits and drawbacks of this permission blockchains. These topics we have to study in the unit 3rd. So in previous session, we have studied what is permission blockchain. So we will go ahead with the use cases and benefits and drawbacks of this permission blockchain. So this is the syllabus of unit 3rd. In this we have to study permission model of blockchain, its use cases, design issues, then test state machine replication, consensus models for the permission blockchains. There are different consensus models like Paxos, RFT, Byzantine fault tolerance systems, then Lampert, Shostak, peace, BFT algorithm, BFT or asynchronous system. So these topics we have to study in the permission blockchain. So we have to understand that when we try to understand new topic, then to become familiar with that topic, it will take some time. So since we have started new topic in this unit permission blockchain, so it will take some time for you and also for me to become familiar and to understand the terms related to this permission blockchains and to understand the concept of this permission blockchains. For preparing this subject, there is a problem of books. The books that I am referring, I got the two books, and in these two books, from that two books, we have studied the unit 1 and unit 2, and this permission blockchain is not available in the books that I am referring for teaching this subject. So from internet, I have to collect the different sources, different research paper, different material, and then we have to prepare the sessions for this unit. At the end of this unit, we will have a complete notes of this unit collected from the different sources. So in previous session, we have taken the introduction of this permission blockchain. So in permission blockchain, the nodes are trusted nodes. The nodes are already known nodes. The nodes, or we can say the users or the peoples that participate in the permission blockchain. That participants are trusted participant. That participants are already known. And if some industry, in some industry, if they want to use a platform to share their information and to do the different types of transactions, these permission blockchains can be used for particular organization. In that organization, the peoples are already known peoples are pre-selected, pre-approved people, and such type of group of peoples can come together, group of nodes, group of participants can come together, and they can form this permission blockchain. These permission blockchains are also called federated or consortium blockchains. So these are the alternate terms, federated and consortium blockchains that is used for this permission blockchain. So this blockchain does not allow any external people to take part in the blockchain. So it will not allow any other external people that are not known. Such type of peoples are not allowed to participate in the permission blockchain. So in permission blockchain, the peoples are already known, peoples are already trusted. So there are many benefits of this permission blockchain, including higher scalability, and is an excellent choice for enterprise companies. So this permission blockchain is excellent choice for the industries or companies to share their data and information. So industries such as finance industry, supply chain industries can benefit immensely through this permission network. So there are various examples of this permission blockchain, various implementations of this permission blockchains. The key permission blockchains include Quorum, Coda, and Hyperledger Fabric. So in this session, we will try to study these use cases. Use cases means where this permission blockchain is implemented. That use cases, real world use cases, we have to study. We have to take the introduction. We cannot go into the details of this Quorum, Code, and Hyperledger Fabric. So we will see only the introduction of these use cases, Hyperledger Fabric, Quorum, and Coda. So you can see the first use case of this permissioned blockchain is Hyperledger Fabric. So this Hyperledger Fabric is one of the Hyperledger projects hosted by the Linux Foundation. It is a decentralized operating system for permissioned blockchains that can execute distributed applications. So this is a decentralized operating system that can it is a decentralized operating system for permission blockchain, and it can execute the decentralized applications, dApps, written in general programming languages, and these applications are written in general programming languages such as Go, Java, or Node.js. So this Hyperledger Fabric is composed of nodes whose identities are given by a membership service provider. So in this Hyperledger Fabric, we know that in permission blockchain there is a proper governance for selecting the nodes, the users, nodes, or people who will participate in the permission blockchain that are selected by the authority. And in this Hyperledger Fabric, there is a membership service provider which selects the node. So this Fabric network is composed of nodes whose identities, these nodes are whose identities are given by membership service provided. So these nodes can be there are different types of nodes, and nodes can be clients that propose transaction to execute and broadcast them for ordering. So nodes can propose the transaction and execute the transaction and broadcast the transactions for their ordering in the blockchain. And peers, there are peers nodes that maintain the ledger and state of the ledger. And ordering service nodes, there are ordering service nodes that establish the order of all transactions. So there are different types of nodes in the Hyperledger Fabric. So we will not go into the details of this. We just have to take how this permission blockchain concept is used in the Hyperledger Fabric. So this is the project hosted by the Linux. It is decentralized operating system for permission blockchain that can execute the distributed applications. And these applications are written in general programming language such as Java, Nodes.js. And in this Hyperledger Fabric, the network is composed of the nodes whose identity is given by the membership service provider. So this Hyperledger Fabric uses smart contracts called as chain codes for implementing the application logic. So we have studied what is smart contracts. These contracts are automatically executed whenever the block is inserted, whenever some transaction is done in the blockchain. Then this smart contracts will enforce the conditions. Whatever the business conditions, that conditions are enforced by these smart contracts. So in unit 1 we have studied the concept of smart contracts. So Hyperledger Fabric uses smart contracts called chain codes for implementing the application logic. The platform natively implements Solo, a voting based consensus protocol consisting of endorsing nodes, executing the transactions and validating them in compliance with the endorsement policy. So there are endorsing nodes. These nodes consist of voting based consensus protocol. And So this hyperledger consists of a voting based consensus protocol that consists of endorsing nodes, and these nodes are executing the transactions and validating them with the endorsement policy. However, other consensus protocols such as PBFT, RAFT, then this Kafka, this can be also plugged in. So we have a separate unit on this hyperledger, last unit, unit 6. So we will study what is this hyperledger in detail in unit 6. So this is the one of the use case of this permission blockchains. Then next example of the permission blockchain is Quorum. This Quorum is a permission blockchain based on Ethereum blockchain that is aimed at the financial industry. So this Quorum is a permission blockchain. It is for financial industry, and this Quorum permission blockchain is created by the JP Morgan. It brings several advancements. So it is based on Ethereum blockchain, and it brings the several enhancements to the Ethereum blockchain. That enhancement we have to see. The first enhancement is the privacy. So in this Quorum, it is possible to create the private contracts and transactions whose payload is only visible to the participants that are specified in a parameter of the transaction. So in this Quorum, it is possible to create the private contracts and transactions, and these contracts and transactions whose payload is visible to the participants that are already specified in the settings of this Quorum, or you can say in the parameters of the transaction. So public transactions are still possible. Private transactions and public transactions are possible in the Quorum. There are different alternate consensus protocol used for Quorum. So this Quorum, in this Quorum, other protocols for consortium blockchains such as the RAFT based consensus protocol, then Istanbul BFT are also available. So permissioning, then the third enhancement is permissioning. Only known and authorized peers defined in smart contracts can join the network. So only the peers that are defined in smart contracts, that peers can join the network, and it has higher performance. So these are the various enhancements in the permission blockchain as compared to the Ethereum blockchain. So this is one of the use case of the permissioned blockchain. So we cannot go into the details of this. We just have to take the introduction of these use cases. There are three use cases we are taking into this session: Hyperledger Fabric, Quorum, and Corda. So next is Corda. So this is one of the use case of the permission blockchain, Corda. R3 Corda is an open source permission platform developed by R3. So Corda follows the know your customer principle. Each node has to prove its identity to be authorized to join the network. So when the node wants to join the permission network, the node has to prove its identity. There is a node called doorman node. The doorman node is the node in charge of validating the identities and distributing the certificates. So this doorman node will check the validity of the entities that will participate in the permission blockchain, and it will distribute the certificates. The network is also composed of other nodes. So the network consists of one or many notary nodes. Their role is to validate the uniqueness and the sequencing of the transactions without global broadcasting. So without broadcasting the transaction to all the peer nodes, there are some nodes, notary nodes, that will validate the uniqueness of the transaction and sequencing of the transaction. So there are two types of consensus have to be reached in the Corda: validity and uniqueness. So validity is checked by each signer before signing the transaction. So before signing the transaction, each signer will check the validity of the transaction, and uniqueness is checked by the notaries. The notary nodes will check the uniqueness of the transaction. So smart contracts written in JVM languages are supported, and Corda supports the development of decentralized applications written in Kotlin. So this is the one of the use case of this uh, permission blockchain. This R3 Coda is an open source permission platform developed by R3. It follows a know your principle. Each node has to prove the identity. There is a doorman node which checks the validity of the nodes, identities of the nodes, and it distributes the certificates. So there are other nodes also, notary nodes and signer nodes. Notary nodes are responsible for validating the uniqueness and sequencing of the transaction. And two types of consensus are used. Consensus has to be reached in Coda, validity and uniqueness. So this is all about this Coda. Then we have studied in previous session what are the benefits of this permissioned blockchain: efficient performance, it has proper governance structure, decentralized storage and cost. These permission blockchains are cost effective. So we will try to go into the details of this benefits of permission blockchain. So the first benefit of the permission blockchain is efficient performance. So as compared to the permissionless blockchains, this permission blockchain offers the better performance. The reason behind that is that it has limited number of nodes. That nodes are pre-selected, the nodes are pre-approved, and because of that, this permission blockchain offers the better performance as compared to the permissionless blockchain. And this removes permission blockchain removes the unnecessary computations required to reach the consensus on the network. So we know that in permissionless blockchain we have complicated consensus algorithm. So such type of complicated consensus algorithms are not necessary in the permissioned blockchain. So it removes the unnecessary computations required due to the consensus on the network, improving the overall performance. So we know that in permissionless blockchain, every minor node tries to solve the mathematical puzzle. But in this permission blockchain, the nodes that will validate the transaction, that the role of nodes is defined. Some nodes will validate the transaction, some nodes will sign the transaction. This removes the burden of consensus mechanism. There is no burden of consensus mechanism in the permissioned blockchain. So on top of that, the permission networks have their own predetermined nodes for validating the transaction. So for validating the transaction, there are predetermined nodes, and every node will not try to validate the transaction. There are some nodes that will select the entities that will participate in the permission node. There are some nodes that will validate the transaction. The role of node is defined. So there are limited number of nodes, and this permission blockchain is has the better performance as compared to the permissionless blockchains. Then next benefit of this permission blockchain is proper governance structure. So permission networks do come with an appropriate structure. So as we have discussed in the previous slide, the role of nodes is defined. Some nodes are for validation, some nodes are for identifying the users that will participate in the network. Some nodes will validate. So the nodes, the proper structure is defined. So these permission networks come with an appropriate structure of governance, and this means that this structure is organized structure, and administrators also require less time to update the rules over the network, which is considerably faster as compared to the public blockchain. The public blockchain network suffers from the consensus problem. Every node tries to propose a node using the consensus mechanism in permissionless blockchain, and this creates a overhead in the network. So such type of typical consensus mechanism is not required in permission blockchain. So the this permission blockchain has the advantage over the permissionless. The permissionless blockchain suffers from the consensus problem, as not all the nodes work together to get the new update implemented. So in permissionless blockchain, all the nodes will try to use their resources to update the network, to insert the block in the blockchain. So these nodes might place their these nodes might place their self-interest above the needs of the blockchain, and which in turn slows the updates to the whole network in permissionless blockchain. So in comparison, permission blockchain doesn't have the problem, as the nodes work together to move the updates faster. So faster updates are possible in the permission blockchains as compared to the permissionless blockchains. The next benefit is decentralized storage. Permission networks also make proper use of the blockchain, including utilizing the decentralized nature for data storage. This is the one of the benefit of this permission blockchain. Next benefit is cost effective. No doubt these permission blockchains are more cost effective as compared to the permissionless blockchains. Then there are some drawbacks of these permission blockchains also. So we will see the drawbacks. The first drawback is compromised security. These permission blockchains are less secure as compared to the permissionless blockchains. So in public or private blockchain, there is a better security, as the every node participate in a consensus method properly. But in this, there are only few nodes that propose a block, and there are only few nodes that select, say, users in the permission blockchain. So in the case of permission blockchain, this might not hold true. The security of permission network is as good as the members integrity. The security depends on the integrity of the nodes, because there are only few nodes that are controlling the permission blockchain, and if these nodes misbehave, then these nodes may create the problem in the permission blockchains. This means that there are small section of a permission system that can work together. There are small group of people, small group of nodes that work together to modify the data stored in the permission blockchain, and in this way the integrity of the network can be compromised. These nodes can try to manage the network. So this is the problem with the permission blockchain. So to resolve it, the system would have proper permission set, so that these nodes will not act badly to compromise the network. And this may cause the undesired effect on the network. So to avoid this undesired effect on the permission blockchain, if the system could have proper permission set, so these bad actors cannot merge together to cause the undesired effect. So this is the one of the problem with the permission blockchain. Then next drawback of this permission blockchain is about the control, censorship, and regulation. So in ideal world, this permission blockchain should work as that of a public blockchain. So as the blockchain is a decentralized network, and ideally it should work like a public blockchain, but in this permission blockchain has the proper governance mechanism. So there is censorship, control, and regulation. However, the regulation brings the censorship to the network. This regulations, this censorship is contracting to the decentralized concept of the blockchain. So this censorship, where authority, where the governance mechanism can restrict a transaction to control it from happening, because there are some nodes that are controlling the transaction, and these nodes can restrict a transaction in the permission blockchain, and this is the threat to any organization or business. Some nodes are trying to control the this permission blockchain. So this may happen in the permission blockchain. So there are a threat to any business or organization that is using the permission network. So this approach also stops the permission network from making the most of the benefits of this blockchain, as the blockchain is a network decentralized. But in permission blockchain, it can create a monopoly, because there are some nodes that have the authority to control the network, and these nodes can restrict other nodes from completing the transaction in the permission blockchain. So these are the drawbacks of this permission blockchain. So students, in this session we have studied the use cases of permission blockchains. We have studied, we cannot go into the details of this use cases. We have studied hyperledger, fabric use case, coda, and quorum. We just have to take the introduction. And these use cases can become a very big topics. There may be a separate subject on this Ethereum blockchains, hyperledger, fabric, but we just have to see the uh, examples of this permission blockchain. Then we have studied the benefits of permission blockchain and drawbacks of permission blockchain. So in the next session we will try to study the design issues, or we can say challenges we have to face while designing this permission blockchain. So today, in this session we will stop here. Thanks for watching session. Goodbye.